An example of the fifth form using partial fraction decomposition is the function 5x minus 2 divided by x cubed plus 3x minus 4. The factoring for this one isn't as straightforward as the previous examples. We'll walk you through it. You get 5x minus 2 in the numerator on top still. Leave that alone. The denominator, because I don't have an x squared in there, I know it's canceled out somewhere once, when I factor it out. So the way the setup for this one is going to go is I'm going to have an x here, and I'm going to have an x squared here. And these last two numbers will still be a product of this last number here, 4, the numbers here and here. But I'm going to have a third unknown right here. That's going to allow that x squared that's not there to be gone. The numbers for 4 that I'm going to use are 1 and 4 because those add up to get 3. So I'm actually going to use positive 4 and negative 1 because those will add up to get 3. And I'm going to attach the negative 1 to the x, and I'm going to attach the positive 4 to the x squared function. And then what goes here is what's going to allow that square to cancel this x squared. When I multiply 1 to x squared, I get negative x squared. So what I want to add here is I want to add a positive x, because when I multiply x to x, I'll get a positive x squared, and that negative x squared and positive x squared will cancel. Now it's more easy to see that this fits form 5. The first fraction is pretty straightforward. I just get a over x minus 1. This second fraction, though, you might be saying, we still have a square in the denominator. And can we allow that? We can, because this is no longer factorable. We can't factor this further using whole numbers. So it's okay to leave it like this. What we do when we leave it like this is we count for it in the numerator by attaching an x to the first constant and adding a second constant to it. So this then becomes bx plus c over x squared plus x plus 4. Everything else is the exact same as the previous 4 examples. We're going to multiply the denominator to get rid of it. Parts of it will cancel out on the right-hand side. Our equation then becomes 5x squared minus 2 equaling a times x squared plus x plus 4. Plus, we have to keep a parenthesis around this bx plus c because x minus 1 is being multiplied to all of that. And then everything else is the same as well. We pick values for x to cancel out the variables to make it solvable. And the first value I'm going to pick is actually going to be, let's let x equal positive 1. Because I can see here, if I pick x to be positive 1, I'm going to be able to cancel b and c out. My right-hand side becomes 3. My left-hand side becomes a times 6, the b times 1 plus c times 1 minus 1 all goes to 0. So I'm left with a equaling 1/2. We haven't had our constants equal fractions before, but this is completely fine and appropriate. Now that I know what a is, I'm going to plug it in to the formula, and I'm going to pick other values to solve for b and c. Let's let x now equal 0, because if I have x equal 0, b will cancel out. The left-hand side of my equation becomes negative 2. The right-hand side of my equation becomes 4 divided by 2, which is 2, plus that b goes away. It's b times 0, which is just 0, right? Plus c times 0 minus 1. So c equals positive 4. I'm going to substitute out c and put in 4. Now I'm going to let x equal negative 1, because I don't want it to equal 0 or 1, because I want to actually solve for b. The left-hand side becomes negative 7. The right-hand side becomes 2 plus, this is a b times negative 1 plus 4 multiplied by negative 1 minus 1 half. So my solution now to the partially decomposed fraction becomes 1 half over x minus 1 plus negative 1 half x plus 4 over x squared plus x plus 4. And we can simplify this to make it look neater. That's the same as saying 1 over 2 times x minus 1 minus, I'm going to take that minus out, x minus 8, because I'm also going to take that 2 out, 2 x squared plus x plus 4. And this is just a way to simplify it to make it look neater. But this is the solution for our partially decomposed fraction following Form 5.